Okay, Faisal, I will solve this problem. Question number 6. Refrigerant is the working fluid in a heat pump cycle consisting of 4 processes in a sequence of transferring heat from outside air at 0 to a house at 22. So there is a heat pump, and the heat pump is using the air outside, which is 0, freezing, to inside the house to heat the house. And he has the following cycles: 3 to 4 adiabatic throttling, saturated liquid from 1 p.m. and to 200 kilopascal. 4 to 1 is evaporator, 1 to 2 is a compressor, 2 to 3 is a condenser. And he has the drawing of the following condenser, and he has the expansion valve, compressor, and the evaporator. Of course, the evaporator you need to give heat, and this you need to give up heat. And he has the temperature and pressure and the quality. How could you solve this? Okay, let's look at this question and try to solve it. Let's look at the first one. The 4 to 1 is an evaporator, the 2 to 3 is a condenser, 1 to 2 is a compressor, 3 to 4 is an expansion. State 1, you have pressure 1, 200 kilopascal. So you go to state 1, 200 kilopascal, and X is 1. So 200 kilopascal, and X is equal to 1. From this you go to the tables, you find H1. 200 kilopascal, which means gas. So H1 is the H gas, to 244.46 kilojoule per kilogram. And V1 is equal, which is V gas. And of course, it is at 200 kilopascal, 0.099867 meter cube per kilogram. You go to state number 2, same way. State number 2 is 1000 kilopascal, 50 Celsius, and there is no quality. So state 2 is 1050 Celsius. You find H2, and of course this is superheated. 1000 kilopascal, it's superheated. So you have to go to the superheated graphs and find at this pressure and temperature to find out what is H2. State 3, the same thing, 1000 kilopascal and X3 is equal to 0. You go to the table and find out H3, which is fluid this time. Okay. And you go to X4, state 4, find from the table P4 and X4. And now what is needed here, you need to find H4. Now, since state number 4, it is the process as starting from the evaporator. Leaving the evaporator is 1. So we need to find out what is getting into the evaporator from the expansion. So H4, HF at pressure 4, fluid, 38.43 from the table, because that's pressure 4, 200 kilopascal, and HG at P4 is 244.46 kilojoule per kilogram. Now from this you could find out H4. H4 is equal to HF. HF is 38.43 plus X4. X4 is 0.334. That's what's given in the table. H gas minus HF. H gas is 244.46 minus 38.43. You'll end up with H4 is 107.244 kilojoule per kilogram. Once we find this, now it was given also. You could go and see it here, that neglect kinetic energy changes of the volumetric flow rate of the R134 at the evaporator. Remember, what was the things? It is leaving the evaporator at the evaporator, okay, which is like at 4. At 4, the evaporator will start, and at 1 the thing gonna leave the evaporator. So at the evaporator, at number 4, what was 0.01 meter cubed per second, determine the following. So he gave you the flow rate. He gave you the flow rate at the outlet to the evaporator. So you do it like this, 0.01 meter cube per second, and we found V1 before, 0.099867 meter cube per kilogram. So the mass flow rate, it's 0.01, that's what's given in the question, over 0.099867, and you're gonna get 0.1 kilogram per second. So what is the rate of heat transfer from the outside air in evaporator? You use this equation to find out the rate of heat transfer from the outside air in the evaporator. Q dot L, M dot, H1 minus H4. So we know M dot 0.1 and we know H1 and H4, 244.46 minus 107.264. You'll get Q dot L, 13.739 kilowatt. And now what is needed in the question is the rate of heat supplied to the house at the condenser, because it will leave from the evaporator to the condenser. So this is Q dot H is M dot H2 minus H3, because it's the condenser, remember? It's 2 to 3. So H2 minus H3, and then you could find out 17.56 kilowatt. And now the power requirement for the compressor is W dot 1,2. Remember, the compressor is 1 to 2. Compressor is 1 to 2. So W naught, to find the power requirement of the compressor, it's M dot, open the parentheses, H1 minus H4 minus H2 minus H3. So we know that H1 minus H4 is Q dot L, and we know H2 minus H3 is Q dot H. So we subtract these two, because we found 17.56 here, and we found 13.739 here. So this minus this would give you W dot 1,2, which is the power requirement of the compressor. To find the COP of the heat pump, it's by dividing Q dot H over W dot N, 17.56. Okay, this is the rate of heat applied to the house at the condenser, over 3.82, which is the work done by the compressor. This would give you 4.6, and you could also find extra things like rate of heat absorbed from the outside air. Q dot L is Q dot H minus W dot N, 17.56 minus 3.82, that will give you 13.74, and that is the rate of heat absorbed from the outside air.